in bouncing ball 101, let's say, we need to start with some question, because we are animators. We want to put a spark of life in a circle. You literally do not need a powerful graphics in order to, to create the illusion of life. A circle in 2D, a sphere in 3D, it's enough. You don't even need colors, texture, nothing. However, as I said, we have to have our logical brain in action. And from the physics point of view, when we want to express motion, we have to think as a laws of motion. And I don't want to give like a full spectrum of laws of motion created by Isaac Newton, the English mathematician, and which he literally invented the math and the laws of motion, also called the classical physics or the Newtonian physics, with a cause and effect action. However, it's super important that in animation that we are looking at mass, right? How heavy is an object, right? So that's mass. It gives us a feeling. We show an illusion of mass to an audience. But then we also have the second characteristic, which is volume, right? How large or how small is an object. And then we have the material, which may tell us information about the flexibility or rigidity of an object. So mass, volume, and material in animation are characteristics which we need to understand in order to create a good illusion of life. So in real physics, we measure the amplitude, the height of each bounce. We also measure the period, which means the time between two consecutive bounces. And regardless of the ball, regardless of what surface we are experimenting this drop, the physics is telling us that there is always an attenuation. Regardless if you have 5 bounces, 50 bounces until the ball will settle, every bounce it will be lower and lower in amplitude and height, but also the time between two consecutive bounces, it will become faster and faster until the whole energy is being dissolved from the ball. So as an animator, this is super important to understand, because this creates that illusion of mechanical believability. As I said at the beginning of the lecture, we need to understand real world physics in order to create that illusion of gravity, of the things being pulled down, illusion of the mass, how heavy objects are, and illusion of velocity or acceleration, because nothing in this world, nothing organic moves its constant speed, right? There is always a non-linear motion. So what you see in the right are animation. It's just an animation, and it, as you can see, the golf ball is basically has the highest elasticity, the highest bounciness, because it simply needs more time to settle. Opposite to that, obviously, is the bowling ball, which is a heavy metal ball, doesn't have elasticity, doesn't have deformation within the surface. Let's do now pass number 4, and just let's reinforce those contacts and recoil. And after that, we're gonna work a little bit in slowing down the ball in the highest positions. But now we need to make stronger contact, because we really need to create the illusion of an impact and of a recoil. And not to mention that this recoil is giving us the bounciness of the ball. So as you can see, 7, 8, 9 are 3 keys which you have to do within every contact. 7 and 8, we need 2 keys in order to create the impact. One is just like a small contact, it's not a full contact. I'm just touching the ground with the tip. The ball is being elongated due to gravity, is being pulled down. Then I have a full contact, and then I have the recoil. So it's super important to create this illusion. So let's I'm gonna duplicate ball pass 3 and make it 4. Duplicate layer, make this 4, hide the other one, and now I have a contact at frame, as you can see, at frame 7. I'm on 7 here, and we're gonna scale this. I'm gonna zoom. Let me make a little bit more space here on this scene. My pivot is in the center, so all my deformation is gonna happen on this one. I'm scaling on 2 axes at the same time because I don't want to lose the volume. And this is the first contact. The ball is being stretched due to gravity. The ball is touching the ground only with a tip, let's say, but also is being tilted. Let me zoom out, along the arc. Is being rotated along the arc. So this is first contact. Number 8, the software by default, is pushing the ball up, but I'm gonna take my ball and place it on the ground again. It's gonna be flat, not rotated. I'm gonna squash it. Make sure you don't lose the volume. We're gonna do another check. So if I'm just grabbing between 7 and 8, I have to create the illusion that I have a fixed point in space, a stretch contact, and then a full contact. Gonna make it something like this and push it down. So a fixed point is super important. This creates the illusion of the impact. And then on 9, as you can see, I have the recoil. Make sure you do not rotate in the different direction. And I'm just taking the ball and let's say in my head I always keep in the back of my head that this thick line here is like it's also is the head of the ball, right? And I always want that to face up, unless I'm doing some kind of rotation. But since this ball doesn't have any kind of texture, even though I rotate the ball along its pivot, it's not going to be visible, so you can still do that. I just want to create the illusion of the recoil. This one looks a little bit more larger, so let's zoom a little bit. First contact at 7, have a stretch contact. The ball is falling due to gravity. Full impact, a squash. Make sure it's kind of the same volume, and all just place it on the ground. 7, it's a recoil. Is basically I should have the same volume like 7 and 9 should be kind of the same volume. Gonna make it a little bit larger. Take your time, because this is into the animation. It's super important to have the same volume. You don't want to get at the end of your animation with a teeny mini ball when you started with a large one. And now this is super important why this happened, and I'm going to explain to you what happened. I'm going to open up the graphs. The thing is that when I have blocked the keys of the contact, I have stayed on auto key, and I should have add keys manually, because when I add keys manually, it adds on all the channels on the same time. So just by staying on auto key, it added only keys on the channels that hold the information above the position in space, not the volume, not so only the location initially. Now the software doesn't know the scale, doesn't have any keys on the scale like we have done. And remember to read the graphs are actually flipped down. Positive in the graphs, it's the bottom row, and negative is up. It's vice versa. So we need to copy the natural shape and volume of the ball from the first key and paste it on the top of the arc. So it is simple. Right click, copy properties, go to your position where you want. So remember, we are on both scale and X in the same time, right? And right click, paste property special, and you'll see here all the channels. I want position. I don't want to copy position because I already have the position. I set it up. I no longer have a rotation too because I haven't rotated anything. I don't have a skew. I only have scale, and hit OK. So let's grab and talk about it. Natural shape, ball falls down, is starting to stretch, contact stretch, squash, full contact, recoil stretch. It gets into normal position up, and here I'm gonna do the same thing. We are on the fourth pass of this animation, and now it's time to work both with the tail and with the body in the same time, meaning that we work both with the main action and with a secondary action in a way that we gain more follow-through of the tail compared to the body. So I think we can just close our reference because we have used as much as we can, and it's time to literally understand the motion. As I said, our brain picks up the motion much faster than our eyes, right? Things are happening in way faster than 1 second, and we need to make sure that we can work within that fast timing. So like we've done in first part of this exercise, we have just scrub and go frame by frame. So I'm using again my arrow keys. Just go frame by frame and reading the tail and trying to understand, okay, or look for the moments where my tail is a straight line or a diagonal. So that is something which I can start with. We want to avoid that rigidity in the tail, or wherever the tail is not pushed as an S curve. For example, here it can be even more pushed. I can work the bend here on the body and the tail again can be more pushed, and scrub the tail here. It can be even more pushed. It can be super stretched, for example here, because I want to create the illusion of speed. A straight horizontal line, this is just horrible. It's just something generated by the software. I don't even have a key in this segment. And then when I have this settled, nothing happens in the middle of the tip of the base. So I do have something to work with. I'm starting to see things. So let's start with things which are the obvious. Exactly in the middle of the screen, I can go and push, make the illusion of speed, right? Push this a little bit more. I can take my tail, make it, I'm gonna stretch it. I did say that don't stretch the tail, but this is like, in animation actually it's called elongated in between, right? Because I'm elongating, and I can even destroy the forms in a way that it just helps me to increase the illusion of speed, right? Super fast action, it's a distortion of the shape that is happening. But the overall process is the same. I'm telling you, it's just a back and forth process between analyzing reference, analyzing people work, do your own notes, go into the animation software, block something out, critique your own work, and then go and implement new ideas. That's it. And once you have this kind of flow, of workflow, in working with multiple things in the same time, you just have to feel the animation. It's not about seeing it. As I said, we animate in less than 1 second, in microseconds. So we need to scrub the animation. We scrub the time in order to sense, in order to train our mind to feel microseconds of motion.